through the 2014 paper 2 for pure mathematics, unit 1. And it says, let P, Q, and R be three propositions. Construct the truth table for P implies Q and R implies Q. So you're going to construct a truth table for P implies Q and R implies Q. So to construct this truth table for P implies Q and R implies Q, first thing we have to note is that there are three variables. All right, there's three variables. Since there are three variables, then the number of possible outcomes is 2 cubed. 2 cubed is 8. All right, so first thing we're going to do is set up your table. All right, so let's set up our table. And the variables again we know are P, Q, and R. All right, nice. So now let's put in the outcomes. We know that we're gonna have for P it's gonna be 4 true and 4 false. All right, so you can write the 4 true first, then you write the 4 false. You don't have to use true and false. You can use ones and zeros. A lot of people like to use ones and zeros. 1 representing true and 0 representing false. So that's for P. Then for Q, it's gonna be true, true, then false, false, then true, true, then false, false. That gives the 8 possibility for Q. Nice and easy. Then for R now, it's going to be true, false, true, false, true, false, true, false. True, false, true, false, true, false, and true, false. Nice and easy, soft. Now, based on the question, remember, this is what we need to draw the truth table for. So before we can do that, we need to construct the truth table for what is P implies Q, and then we're going to need R implies Q. All right, and after we get these now, then and only then we can be able to look at what's the truth result for the two of them together. P implies Q and R implies Q. So we look at that afterwards. So now P, let's go here now. Now P implies Q, let's put the results them in red. P implies Q, the only time it's gonna be false is when P is true but Q is false. So you're gonna look for when P is Q but Q is false. That's somewhere right here. P is true and Q is false. Here so as well, P is true and Q is false. So these are the only two times when P implies Q is going to be false. Everywhere else it is true. All right, everywhere else it is true. So you can just put true, 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 and true. Nice. Then for R implies Q, the only time it's going to be false is when R is true and Q is false. So R is true and Q is false. R is true and Q is false. So right here again, R is true and Q is false. R is true and Q is false. So these are the only two places. All right. So let's write that it's going to be false here and it's going to be false here. Everywhere else is true. This is true, 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 and true. Finally, what we're asked to draw a truth table for is actually P implies Q and R implies Q. This is what we want. So we need AND of these two. We need AND of these two. So what that is going to be is true and true is true. True and true is true. False and false is false. True and false is false. True and true is true. True and true is true. False and true is false. True and true is true. All right? And so this is the answer. Nice and easy, and you get your 5 marks. No issues. Soft. Let's go to the next part of the question. The next part of the question says a binary operator is defined by, I don't know what that is. We can just call it circle plus. A binary operator is defined by circle plus, and they're telling us that y circle plus x is equal to y cubed plus x cubed plus ay squared plus ax squared minus 5y minus 5x plus 16. Right, and it says state given reason for your answer if circle plus is commutative. So again, it tells us that, let's write down what it tells us. It tells us that y circle plus x is equal to y circle plus x is equal to y cubed plus x cubed plus ay squared plus ax squared minus 5y minus 5x plus 16. Now, to show if it is commutative, there are many ways you can do it, but ultimately you want to show that y circle plus x is equal to x circle plus y. So you can even give it some values, right? You can probably let y equal 1 and maybe x equal 2. Right, just give it some value. If y equal 1 and x equal 2, what you get is 1 circle plus 2. 1 circle plus 2 is equal to 1 circle plus 2 would be 1 cube, which is 1, plus 2 cube, which is 8, plus 8 times y squared. Y squared is 1, so it just becomes plus a, plus this becomes 2 squared is 4. That becomes 4a minus 5 minus 10 plus 16. And so what you get is 1 circle plus 2 works out to be 1 plus 8 is 9. 9 minus 5. 9 minus 5 is 4. 4 minus 10, let me see that. 4 minus 10 is negative 6 plus 16 is 10. So 1 circle plus 2 give you 10. Now, if you can show that 2 circle plus 1, if this give 10, then clearly commutative. So this is just proving it using an example. So 2 circle plus 1, right? 2 circle plus 1. You would see that you would get 2 cubed is 8 plus 1 plus ay squared. Ay squared is going to be 4a plus ax squared is plus a. I know what you're saying. I forgot to say 10 plus 5a. I know. I don't know why I left off the 5a. 10 plus 5a minus 5y, which is minus 10, minus 5 times 1, which is 5, plus 16, and this still works out to be 10 plus a, right? Now these are the same, these are the same values that we're getting. So since we're getting the same values, you can conclude that y circle plus x, that's what I call this binary operator, y circle plus x, it's equal to x circle plus y based on our example, right? And it doesn't matter which number you choose, it's going to be the same, all right? And so circle plus is, so therefore circle plus is commutative. So that's how you show that. Nice and easy, soft. So that's the first part. You didn't have to actually use examples. You could have just used x and y itself. But it looks trivial to me that way. Now the second part says, given that f of x is 2 circle plus x, f of x is 2 circle plus x, and x minus 1 is a factor, find the value of a. So they're telling us that f of x is equal to 2 circle plus x. So if f of x is 2 circle plus x, what we're doing is we're going to replace y with 2. Anywhere y is, we replace it with 2. So y, 2 cubed is 8, plus x cubed, 2 square is 4, so that becomes plus 4. Let me see, 2 square is 4, that becomes plus 4a, plus x, 8a, x squared, and replace y with 2 again, you get minus 10, and minus 10 right here, but minus 10 plus 16, I'm just going to put plus 6, minus 5x. Now you can go further and simplify this by saying that this is equal to 8 plus 16. 8 plus 6 is 14. So we can rewrite this in the form that this is actually x cubed plus ax squared, x cubed plus ax squared. Where's our x term now? Minus 5x plus 14 plus 4a. All right, would have need some space. So let's not quinge it up right there. Let's make some space. So we're saying f of x is actually x cubed. We're just going to arrange it in descending powers of x. So we have x cubed plus ax squared minus 5x plus, now 8 plus 6, 8 plus 6 is 14. So you get plus 14 plus 4a. All right, nice and easy, soft. Then what was the next question that they asked, or they said? The next bit of information is that they said that x minus 1 is a factor. If x minus 1 is a factor, then they're telling us that f of 1 is equal to 0. If f of 1 is equal to 0, then that implies that we can put in 1 cube and get 1 plus a. So we're going to get 1 plus a minus 5 plus 14 plus 4a and 4 plus 4a, and that is equal to 0. Nice. Just make sure putting everything correct. 1 cube is 1. 1 square, that's good. Minus 5, this is 5. Now 1a plus 4a is 5a. So this implies that 5a is equal to, we're going to bring everything over to the other side. 1 minus 5 is minus 4, and minus 4 plus 40, that is 10. So when we bring everything to the other side, 5a is equal to minus 10, and so a is equal to negative. Divide through by 5, a is negative 2. So that's the answer. All right, so this was the first part. This is the next part. A is minus 2. Easy, soft. Now let's go ahead and look at the next part of the question. Next part says factorize f of x completely. Given that we know the value for a now, we can rewrite f of x as f of x is going to be equal to x cubed, and it was plus ax squared, and a is minus 2, so it's actually minus 2x squared. So that's minus 2x squared. Then we have minus 5x plus 14. 14 plus 4a, but 4 times minus 2 is minus 8. 14 minus 8 is 6. So it's really just plus 6. All right, nice and easy. Now, you could go ahead and use factor and remainder theorem and factorize this, but this is what I'm going to do. All right, this is what I'm going to do. I'm just going to factorize them in one go. How do I do that? Let's find out. They told us that x minus 1 is a factor. All right, I'm going to factorize it in one go. Now, I need the other two roots. I know this has to be x and x. I know that the sum of the roots need to be 2 and the product need to be 6. So the next two roots I need, when I multiply the 3 roots, if one root is 1 root should be something here and another root here. I know that the product of them should be 6. So let's say I call this root. Let's say I call this root a and b, right? Then I know say a times b times 1 must equal to minus d over a, which is negative 6. All right? And then I know that when I add the 3 of them, I know that when I add all of them, I know that I'm supposed to get 1 plus a plus b. Yes, 1 plus a plus b. I know that the sum of the 3 roots is going to be 2. So what a and b must be, man? Let's try 3 and negative 2. So we're going to just try. So trying 3 and negative 2. 1 plus 3 is 4. Bingo. Plus minus 2 is 2. So 3 and negative 2 works. 3 and negative 2 works. So good. Yep. So the other roots are, so just writing them down, that the roots are, so not all the time you need to be doing that polynomial division. So the roots are 1, 3, and negative 2. Right? So now we can write the factors. It's going to be x minus 3 times x plus 2. That is it. And you can check it. You add up the roots. 1 plus 3, 1 plus 3 plus minus 2. That should give you 2. When you check it, the product of the 3 roots will give you minus 5. You can check it. So that means the product by 2, that means 1 times 3 plus 1 times minus 2 plus 3 times minus 2, that it will give you minus 5. So not all the time you need to be doing polynomial division, right? Just use sums and products of roots. So that takes care of part B. This is part B. Tired of just factorizing every time. Every time people are just factorizing. Why you want to be factorizing all the time with polynomial division? Now let's look at part C. Part C is a proof by mathematical induction, and it wants us to prove that 1 square plus 3 square plus 5 square plus blah 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 plus 2 to the n minus 1 square is n over 3 times 4n square minus 1. So all of that, you can call it maybe a statement Pn, and Pn is a statement such that we're summing from r equal 1 to n of 2r minus 1 all squared. You don't have to use the letter r as a dummy variable. You can use t, you can use s, anything, but you will commonly use r. We stick with r, and that's equal to n over 3 times 4n squared minus 1. So now let's get it. So now we're going to start with when n is equal to 1. All right, when n is equal to 1, when n is equal to 1, what we're going to get is the left-hand side becomes, your left-hand side is just the sum from r equal 1 to 1 of 2r minus 1 square, and all of this just works out to be 1 square, which is 1. All of this works out to be 1 square, and 1 square is equal to 1. All right, this is step 1. All right, then your right hand side is going to be equal to, when you put n as 1 in the right hand side, you're going to get 1 over 3 into 4 times 1 square is 4 minus 1, and so 1 over 3 times 4 minus 1, that is going to be 3 over 3, and 3 over 3 is 1. So good there. So again, so therefore we can conclude, therefore P1 is true. So P1 is true. Now that P1 is true, we need to show that we need to assume Pn is true. And so when n equal k now, that's step 2, when n is equal to k, so let n equal k. So now that we let n equal k, all right, now that we let n equal k, we're just saying that the statement is going to become the sum from r equal 1 to k, sum from r equal 1 to k of 2r minus 1 square. And this is equal to n over k over 3 into 4k squared minus 1. And we're going to assume that n equal k is true. All right, that's with n equal k. This stage you assume. So you're going to assume n equal to k is true. Assume that this step is true. So since we assume that it is true, we're just assuming. Now step 3. Now we need to show that n equal k plus 1 is true if n equal k is true. All right, so let n equal k plus 1 now. So when you let n is equal to k plus 1, this is what we are going to get. When n is equal to k plus 1, we're pretty much asking to find the sum from r equal 1 to k plus 1. The sum from r equal 1 to k plus 1 of 2r minus 1 all square, and the sum from r equal 1 to k plus 1 is equal to the sum from 1 to k, and the sum from 1 to k is this. The sum from 1 to k, which is k over 3 times 4k squared minus 1 plus the k plus 1 term. How do we get the k plus 1 term? We'll go in here and replace r with k plus 1. So that's going to become 2 times k plus 1, 2 times k plus 1, minus 1, all square. Nice and easy, soft. And we need to simplify out this now. All right, now this is really 2k plus 1. All of this is really 2k plus 1. So let's write that. All of this is really k over 3. This is really k over 3 into 4k squared minus 1 plus this part is really 2k. This is really 2k plus 1 all square. That's what we have, 2k plus 1 all square. All right. Now look what I'm going to do. Since I have a k over 3 right here, right, which looks, I want to have a 3 over 3 right here. So let me put it in a different color. You might say, so sir, why are you putting a 3 over 3 right there? Well, I'm putting a 3 over 3 right here, so it looks easier for me to factor out 1 over 3. That's the first thing I'm going to do. Let's do that around here. I'm going to factor out 1 out of 3. So what we're finally getting now is the sum from r equal 1 to k plus 1 of 2r minus 1 all square is going to be equal to, we're going to factor out 1 out of 3. We're going to factor out 1 out of 3, and we're going to be left back with, factoring out 1 out of 3, we're going to have k times 4k squared minus 1. We're going to have k times 4k squared, k times 4k squared minus 1. All right, and that is plus. When I factor out 1 over 3, I'm left back with 3 times 2k plus 1 all square. That's what I have. Nice and easy. So what do I do next? I continue. So I have 1 over 3 into, all you're going to do now is expand inside this bracket. K times 4k squared is 4k cubed. Then k times minus 1 is minus k plus 3 times, now I need to expand what is 2k plus 1 all square. 2k plus 1 all square is first term square. So 2k squared is going to be 4k squared plus twice the product of the two, which is plus 4k, plus second term square, which is plus 1. Cool. So that's what we get. So now we can do one more, expanding in the bracket to get, this is going to be equal to 1 over 3 into, it's 1 over 3 into 4k cubed. So we have 4k cubed minus k plus, no, 3 times 4k squared, that's going to be 12k squared. So we're getting 12k squared plus 12k plus 3. 12k squared plus 12k plus 3. Nice and easy. Now the only thing that we're going to do now is put this together in one pretty frame. We're going to put it together nice and pretty, and we're going to write it as 1 over 3. We're going to write it as 1 over 3 times 4k cubed Then group up our k square terms together. Grouping our k square terms together, it looks like it's just the plus 12k square. Then we're going to group our k terms together. Grouping our k terms together, notice we have a minus k and a plus 12k, so that's 11k. So we get plus 11k. And then what do we have left? We have just our constant, which is plus 3. All right, nice. So we have 4k cubed plus 12k square plus 11k plus 3. All right. Now remember, what are we trying to get? What's the goal? The goal is to show that the sum from 1 to k plus 1 should be k plus 1 over 3 times 4 times k plus 1 all square minus 1. All right, we need to get this to be k plus 1 over 3 times 4 into k plus 1 all square minus 1. So that means we need to factor out k plus 1 out of this. The only way we can factor out k plus 1 out of this is doing polynomial division. Yes, I know it is tedious, but we're going to have to do it. So we're going to do that to the side in red. We're going to do a polynomial division. We're going to factor out k plus 1. We're going to factor out k plus 1. Factoring out k plus 1 out of 4k cubed plus 12k square plus 11k plus 3. K into 4k cubed leave 4k square. 4k squared times k is 4k cubed. 4k squared times 1 is just 4k squared. Then we're going to subtract these two statements from each other. Subtracting them. When we subtract, always put a bracket before you do your subtraction. You subtract them, you're going to get 12k squared minus 4k squared is 8k squared. Plus the 4k cubes cancel, so you have 8k squared plus 11k, and then k into 8k squared, that's just going to be plus 8k, and then you're going to go 8k times k plus 1, that's going to be 8k times k is 8k squared, that's 8k squared, plus 8k times 1 is 8k, and then we're going to do some subtracting. When we subtract them now, we have 11k minus 8k is 3k. So we have 3k plus 3. Good. So we have 3k plus 3. Then we have k into 3k. That just leaves k into 3k. That just leaves plus 3. And then k times 3 is 3k. That's 3k plus 3. When you do the subtraction, clearly you're going to get 0. We don't even need to work it out. Clearly, we're going to get 0. All right, don't even need to work that out. We know that that is 0. No issues with that. All right, we know that's 0. So what does that tell us? That tells us then that we can rewrite this now as 1 over 3. Let me separate these pages. Let me separate this. That's just a rough work. You don't really need this in part of your solution. It's just rough work. All right, this is not necessarily a part of the solution. This is rough work. So this becomes 1 over 3 times, it becomes k plus 1 times, becomes k plus 1 times 4k squared plus 8k plus 3. Now when you get to this stage, now you can actually factor out the k plus 1. Now you're going to factor out the k plus 1 to say this is now factor out the k plus 1. It becomes k plus 1 over 3 times, and you're left back with what's inside the bracket, which is your 4k squared plus 8k plus 3. But remember, this is not how we want it. We don't want to leave it as 4k squared plus 8k plus 3. What are we trying to generate? We're trying to generate, this is what we're trying to generate. We're trying to generate 4 times k plus 1 all square. 4 times k plus 1 all square minus 1. So now I'm going to do some rough work again on the side. I'm going to show you this. What is k plus 1 all square? So this is some more rough work. K plus 1 all square, you're just showing them this. K plus 1 all square, doing some rough work. That is k squared plus 2k plus 1. Alright, this is rough work again. Now, if you were to multiply this by 4, let's say if you multiply this by 4, it would become 4k squared plus 8k plus 4. And so if you were to then subtract 1 from it, then this will just become plus 3. So look. What are we then saying? See there? 4k plus 1 all squared minus 1 is equal to 4k squared plus 8k plus 3. So we can replace all of this with that. So we can say all of this is actually just equal to k plus 1 over 3 times, we can write it now that all of that is 4 times k plus 1 all squared minus 1. Four times k plus 1 all squared minus 1. So therefore, you can conclude now, therefore, pk plus 1 is true. Because we call the statement pn, so therefore, pk plus 1 is true. Now, generally, when you finish, you don't just done this. So always write a conclusion. Always write a conclusion. Always write a conclusion that hence, by mathematical induction, hence by come by to write out that long word, hence by PMI, the statement above is true for all natural numbers. That's your conclusion. This is step 4. Always write your conclusion. Always write your conclusion. Always. All right, that's the conclusion. Hence, by PMI, the statement above is true for all natural numbers. Question 1, soft. All right, question 2 now. Question 2 give us a function f of x, and it says f of x is 2x squared plus 1. So this is your function f of x, and they tell you that f of x is equal to 2x squared plus 1. So if f of x is 2x squared plus 1, what do? They're asking us to find f square x. Now, f square x doesn't mean you square this. F square x means f of x. It means you put f into f. You put f into f. That's f square x. So putting f into x, it really means f of x. All right. So putting f of x into f, we're going to get 2 times 2x squared plus 1 plus 1. So when you simplify this, it's going to be 2 times 2x squared is going to be 4x squared. And then 2 times 1 is 2 plus 1 is 3. So it's 4x squared plus 3. That's f of x. The next thing they're asking you for is fg of x. So let's write what g of x is up here. They're telling us that g of x is equal to x minus 1 over 2 square rooted. So we've done part A. Part B, we want to find fg of x. Now, fg of x means that you put g of x into f. Fg of x means you put g of x into f. So putting g of x into f, we're going to get 2 times x squared. You're going to replace x with all of that. So you're going to replace x with the square root of x minus 1 over 2 all squared plus 1. When we work that out, what we're going to get is the square cancels the square root, and so we're just left back with 2 times x minus 1 over 2. It works out to just be now 2 times x minus 1 over 2 plus 1. So this works out to be the 2 cancels the 2 here. This 2 cancels this 2. And then x minus 1 plus x is just x. So fg of x is x. Nice and easy. Soft. All right. So if fg of x is equal to x, then what does that mean? That is telling us then that the two functions are inverse of each other. So we can state that this the hence or otherwise state the relationship between f and g. So in the second part, we can tell them f and g are inverse functions of each other. That is, f is the inverse of g and g is the inverse of f. All right, so you can tell them that they are inverse of each other. Nice and easy, that's part 2. Now let's go to part B now. Part B says, given that a cube plus b cube plus 3a squared b, so let's write that down. They're telling us that a cube plus b cube plus 3a squared b, and they're telling us that that is equal to 5ab squared. 5ab squared. And then we need to use that to show that the 3 times the log of a plus b over 2 is equal to log a plus 2 log b. Now, before we do this, before we even look at this given part, I want you to first just analyze this, what they have. Let's write it down in red, because this is not a part of the question. This is just jottings. You have 3 log a plus b, 3 log a plus b over 2, right? By laws of logarithm, really and truly, this is just the log of a plus b over 2 all cube. That's just the log of a plus b over 2 all cubed. This is in reality what we have, the log of a plus b over 2 all cubed. So if this is what we have in reality, the log of a plus b over 2 all cubed, let's try to work out what a plus b over 2 cubed is, and then do this some sort of substitution and see if it will give us the actual answer that we want. All right, what do I mean by that? What I mean is I'm going to generate a plus b over 2 all cubed and then try to find what the log of that is and see if I'll get the answer that they want. So this is just jottings. All right. So first thing I'm going to start with is what is a plus b over, let me put it in black. We don't even need to put it in black. Let's change that color to burgundy. So we have a cube plus b cube, right? A cube plus b cube plus 3a squared, all of that is 5a, blah, blah, blah. And we're going to start with this. So in order to start with that, first thing I want to tell you is that a plus b all cubed over 2 cube, and you know that 2 cube is 8, don't it? And so what we really have is that this is really and truly a plus b all cubed over 2. So let's just put in the 2 and write it as a plus b over 2 all cubed. All right, so this is equal to a plus b over 2 all cubed. All right, and in reality, this is just a plus b all cubed over 8. Now, the next thing that is coming to my mind is expanding. I know how to expand a plus b. I know to expand a plus b all cubed. All right, I know how to expand a plus b all cubed. So I'm not going to expand this one, and I'm expanding this one. I'm expanding this one. I know that a plus b all cubed is a cube plus 3a squared, 3a squared b plus 3ab squared plus b cubed. And all of that is divided by 2 cubed, which is 8. Now, as you can see, guys, look at this now. Let me put this in black. Here I have a cubed, I have 3a squared, this part, plus this b cubed. All of this part together is going to work out to be equal to, those three together is this, 5ab squared. So now I get 5ab squared plus, this is now 3ab squared over 8. Now 5ab squared plus 3ab squared over 8 is just ab squared. That part works out to just be ab squared. So what can we conclude, guys? We can conclude that a plus b over 2 all cubed, a plus b over 2 all cubed, we can conclude that that is equal to a b squared. That's what we can conclude. How did I come up with that conclusion? Here it is. A plus b over 2 all cubed is the same as ab squared, right? So now if these two are equal, we can take the log of both sides now. We can take the log of both sides to say that hence the log of a plus b over 2 all cubed is going to be equal to the log of ab squared. So if the log of a plus b over 2 all cubed is equal to log of ab squared, then what that means is if I carry down the power now, that means that 3 times the log of a plus b over 2, 3 times the log of a plus b over 2 must be equal to, I can separate this now as the log of a plus the log of b squared. This is log of A times the log of B squared. Nice. Now this part I can go even further to break it down now as log A plus 2 log B. And that is equal to this over here, which is 3 log A plus B over 2. Nice and easy. So this is what we have solved. All right, so this is the proof of it. Nice and easy, solved. You can write proven. No, you didn't have to do it this way. No, you didn't have to do it this way. All right, there's also alternative methods, such as maybe you could have started by, I know that you would have learned sums and products of roots, and you'd have learned that a cube plus b cube. I think they teach you these formulas. They teach everyone these formulas that a cube plus b cube is a plus b all cubed minus 3ab into a plus b. This is generally what is taught, right? And then the question I told you that a cube plus b cube, right? And then what you could do is the question I told you that a cube plus b cube plus 3a squared b equal 5ab squared could have been brought over this 3a squared b to say that, okay, well, a cube plus b cube is going to be equal to 5ab squared minus 3a squared b. You're wondering, how did I get that? All I did was make a cube plus b cube the subject from what is given. So bring over this. All right. So I would have gotten that, and that's equal to a plus b all cubed. This is equal to a plus b all cubed minus 3a squared b plus 3a squared b plus 3ab squared, sorry. And minus and plus give you minus. This should be minus. All right. Then what you could go further to do is bring over these two over here. By bringing over these two, bringing over this minus 3a squared to over here, it's going to become plus, and so these two cancel each other. This cancel this, and both this cancel this on this side, and then bringing over that becomes minus 3ab squared plus 5ab squared becomes 8ab squared. That's going to be equal to a plus b all cubed. And then when you have this part now, you can divide both sides by 8. When you divide both sides by 8, you're going to end up get that ab squared is equal to, now 8 is 2 cubed, so it really works out to be a plus b over 2 all cubed. And then when you get to this side, you can just log both sides to say, oh, the log of a plus 2 log b is indeed equal to, carry down the power 3 to get 3 log a plus b over 2. So that's what you could do. This is an alternate method. You don't have to do this. My approach is using the traditional method over here. And so this is our method. Depends on how you like to do things. Depends on how you see things. You could even do it other methods, but I'm just showing you the two methods I would implement. Next part of the question. Now, the next part of the question, it says that Solve each of the following equations. So we have equations to solve. These are the nicest things to do when you're just solving equation. It feels like primary school again. You have e to the x plus 1 over e to the x. And you're solving this equation, e to the x plus 1 over e to the x minus 2. And you're solving this equal to 0. Since we're solving this equation equal to 0, we can multiply through by e to the x. By multiplying through by e to the x, we're going to get that this becomes e to the x squared. E to the x times e to the x is e to the x squared plus 1 minus 2 e to the x. And that's equal to 0. So this is now just a quadratic equation in e. So you can just write it in the proper order. This is just e to the x all squared minus 2 times e to the x plus 1 minus 2 times e to the x plus 1, and this is equal to 0. Now when you get to this stage now, you can go further to factorize. You can go further to factorize now, and you can say, well, e to the x squared, in order for that to be e to the x squared, it has to be e to the x multiplied by e to the x. And this is plus 1, so it's going to be a 1 here, and a 1 here. Signs are the same, both of them negative, so minus, minus. And so what you're getting is that e to the x is equal to 1. If e to the x equal to 1, then x must be 0. So that's the solution. X is equal to 0. Anything to the 0 power is 1. So that's the answer. And if you don't believe the answer, you can check it. Put x as 0 in here. So you get 1 plus 1, which is 2. 2 minus 2 is 0. So that's a baby question, right? You don't even need to work it out. Because I could just look at it and say x must be 0, like without working it out. Like, that's crazy. Let's look at the next part now. The next part is a log question. This is now logarithms, and this log part of the question, it is telling us that we have log to base 2 of x plus 1, log to base 2 of x plus 1 minus log to base 2 of 3x plus 1 and they're telling us that this is equal to 2. All right, log to base 2 of x plus 1 minus log to base 2 of 3x plus 1, they're telling us that that is equal to 2. Now, since that is so, this implies that log to base 2, of, we can join them together as 1. This is really telling us that log to base 2 of x plus 1 over 3x plus 1 is equal to 2. That's what that is telling us. That is what that is telling us. Since that is what that is telling us, now remember, the log of a base of a number is equal to a power. And so then this is telling us that 2 squared is 4. And so we can then conclude that x plus 1 over 3x plus 1 is equal to 2 squared by laws of logarithm. This is equal to 2 squared. All right, that's equal to 2 squared. So we can cross multiply. We can cross multiply now to get that x plus 1 is equal to 4 times 3x plus 1. X plus 1 is equal to 4 times 3x plus 1. and then we're going to solve for x. So expanding through, you're going to get that this is 12x, and then 4 times 1, that becomes plus 4, and then over here we have x plus 1. So we need x's on one side, so I'm going to bring this x over here to make it 11x, and I'm going to bring this 4 over here to make it 1 minus 4 is negative 3. Then I divide through by 11 to get x is negative 3 over 11. That's the answer. X is negative 3 over 11. Soft. With a capital T. X is negative 3 over 11. Nice. Now let's look at part D. Part D says, without the use of a calculator, show that the root of 3 minus 1 over the root of 3 plus 1 plus the root of 3 plus 1 over the root of 3 minus 1 plus the root of 2 minus 1 over the root of 2 plus 1 plus the root of 2 plus 1 over the root of 2 minus 1 is 10. Now, all of that is too repetitive. Look what I'm going to do. First thing, I'm going to rationalize them one by one. You might say, that's crazy. Why would you want to rationalize them one by one? Just look why. I know that we have root 3 minus 1 over root 3 plus 1. All right? That's what we have first. If I can just rationalize this one first by multiplying by multiplied by the conjugate of the denominator. So I'm going to multiply it by root 3 minus 1 over root 3 minus 1. When I do that, I'm going to get, this is going to work out to be root 3 times root 3 is 3. All right, root 3 times minus 1 is minus root 3. Minus root 3, that's minus 2 root 3. It's minus 2 root 3. And then minus 1 times minus 1 is plus 1. Cool. Then we're dividing that by root 3 times root 3 is 3. Well, this is just the difference of 2 squared in the denominator now. So it's just a squared minus b squared. So this part just works out to be 3 minus, that works out to be 3 minus 1. 3 minus 1 is 2. So all of this is working out to be 3 plus 1 is 4. That works out to be 4 plus, works out to be 4, not plus, 4 minus 2 root 3 over 2. And then I do the division, and then I'm going to get 4 over 2 is 2, which is going to be 2 minus 2 root 3 over 2 is just minus root 3. So now I have 2 minus root 3. All right, now the next one is that I'm going to have to worry about is root 3 plus 1 over root 3 minus 1. Now I realize that all of this is just the inverse of this. Notice that root 3 plus 1 over root 3 minus 1, that's just the inverse of this. So I could actually just write that this is going to be 1 over 2 minus root 3. If you see that, can you see that? Yep. Think of it. If this was A and this was B, this is A over B. And this will just be B over A. So this must be equal to 1 over 2 minus root 3. This must be equal to 1 over 2 minus root 3. All right? And then I can actually rationalize this. You can rationalize this part by multiplying this by 2 plus root 3 over 2 plus root 3. All right? So when I do that now, what I'm going to get is 2 plus root 3 divided by, this again becomes the difference of 2 squared. It's a squared, 2 squared is 4, minus b squared, which is minus 3. So this answer just works out to be 2 plus root 3. Nice. We're almost there, we're almost there. Now I need to work out what is the root of 2 minus 1 over the root of 2 plus 1. Root of 2 minus 1 over the root of 2 plus 1. All I'm going to do again is multiply by the conjugate of the denominator. What is the conjugate of the denominator? The conjugate of the denominator is root 2 minus 1 over root 2 minus 1. And I multiply by the conjugate of the denominator. It becomes root 2 times root 2 is 2 minus 2 root 2 plus 1. That's what I get when I work out the numerator. Nice. Then in the denominator, I get the difference of 2 squared, which is just 2 minus 1. And so all of this works out to just be 3 minus 2 root 2. And so now finally I need to work out what is root 2 plus 1 over root 2 minus 1. Now I can tell you that root 2 plus 1 over root 2 minus 1, we know that that is just the reciprocal of this, and the reciprocal of this is the reciprocal of this. And so this is just 1 over 3 minus 2 root 2. So all I need to do is multiply by the conjugate of 3 minus 2 root 2, which is 3 plus 2 root 2 over 3 plus 2 root 2. So what do I get? I get that this works out to be equal to, that in the numerator works out to be 3 plus 2 root 2 over the difference of 2 squared is 3 squared minus, which is 9, minus 2 root 2 squared, which is 8. And so that just works out to be 3 plus 2 root 2. So good now, we're really good, we're nice. So now finally I can add up all of these. Finally, we can add up all of these right here. So now we can write that the root of 3 minus 1 over the root of 3 plus 1 plus the root of 3 plus 1 over the root of 3 minus 1 plus the root of 2 minus 1 over the root of 2 plus 1 plus the root of 2 plus 1 over the root of 2 minus 1 all of this is going to be equal to 2 minus root 3. So let's bracket them. The first one is 2 minus root 3, 2 minus root 3 plus 2 plus root 3, 2 minus root 3 plus 2 plus root 3 plus, that's now 3 minus 2 root 2, 3 minus 2 root 2, plus 3 plus 2 root 2, as you can see right here, 2 plus 2 is 4, 4 plus 3 is 7, 7 plus 3 is 10, root 3 plus root minus root 3 plus root 3 becomes 0, minus root 2 plus 2 root 2 becomes 0, and so all of this works out to be equal to 10. So this proves it works out to be 10. That's a solution for this question. Nice and easy, soft. And now finish question 2, and so finish module 2. Now that we finish module 2, we may proceed to module 3. Now we finish module 1, so proceed to module 2. My apologies. Let's get it. So we want to prove now, we want to prove that the cut, of y minus the cut of x, this is module 2 now, question 3. The cut of y minus the cut of x over the sine of y, well, that's not sine, that's cut x, over the cut of x over the cut of x minus the cut of y. That's what we want to do. Okay, and we want to prove it. So this is the left-hand side, of course, LHS. This is our left-hand side. Always start with what your left-hand side is. You want to do this proof. When you start with your left-hand side, you expand out this right here. So let's expand it out. When you're expanding this, cut y, remember cut is cos over sine. So this is cos y over sine y minus cut x is cos x over sine x. And all of this is being divided by cut x is really cos x over sine x. Cos x over sine x minus cos y over sine y minus cos y over sine y. Now that we do that now, this is going to be equal to, simplify what is this now. To simplify this numerator, we multiply up the sine and multiply up sine y, multiply up sine x, multiply up sine y to write all of this as, this is now sine x cos y, sine x cos y minus cos x sine y, and all of this is being divided by sine y sine x. Sine y sine x. Now since this is what we're dividing by, all of this again will be divided by, join this as one fraction again, joining it as one fraction, it's going to be sine y cos x minus cos sine y cos x minus cos, cross multiply sine y cos x minus cos y sine x minus cos y sine x, And this is being divided by sine y sine x. All right, nice and easy. So what do I do now? This is then going to be equal to, now whenever I have a fraction divided by another fraction, I like to rewrite it another way that it is easier to understand. I'm going to rewrite it as sine x cos y minus cos x sine y minus cos x sine y. And all of this is divided by sine y sine x. Nice and easy. And it is divided by, since you're dividing by this, it's the same as multiplying by the reciprocal of this. And the reciprocal is going to be sine y sine x over all of this, which is sine y cos x minus cos y sine x. Nice and easy, soft. So what happens? So this sine y sine x cancel each other. And so we're left back now with this. We're left back with just in the numerator. We're left back with sine x cos y minus cos x sine y, and all of this is being divided by your sine y cos x sine y cos x minus cos y sine x. This works out to be equal to, when you have sine, then cos minus cos sine, that is just the sine of, it's just the sine of x minus y. It's just the sine of x minus y. And this one is just going to be the sine of y minus x. I'm positive that's what we have there. This one is just the sine of y minus x. All right, so now let's see what happened. It says that should be, okay, I see what happened. Throughout this whole time, it was a plus. I had a minus here. This should be a plus. There should be a plus in the denominator, a plus in the denominator. So when I flip it, this is a plus, this is a plus. Okay, no issue. So now we prove it. Should be an x plus y. So now we prove it easy, soft, which is equivalent to our right-hand side. So that was an easy question. Let's go to the next part. The next part says, hence or otherwise, find the possible values of y in the trig equation when that is equal to 1. So straight away, we know it that if you're going to be solving the cotangent, if you're solving that the cot of y minus the cot of x over cot y minus cot x over cot x over cot x plus cot y. If you're solving this now, if you're solving this and you're solving it equal to 1, then pretty much what you're solving is that this implies that what we're solving is the sine of x minus y over sine of x minus y over the sine of x plus y is equal to 1. All right, so that implies we can cross multiply the sine of x plus y to get that the sine of x minus y is equal to the sine of x plus y. This is what we're solving in reality. Sine x minus y is equal to sine x plus y. So you can expand out what all of these are. Sine x minus y is just going to be sine x cos y minus cos x sine y, and that's equal to sine x plus y sine x cos y plus cos x sine y. That's what we're solving. So if this is what we're solving, what can we do? What can we do? Let's think about it. Now, as we can see, we're solving this. All right, I have a sine x cos y here. Let's see what I can do. So if we bring over this, we're going to have sine x cos y. So sine x cos y cancels on both sides. Luckily for us, it cancels. If we subtract sine x cos y from both sides, we're going to actually see that we're just getting minus cos x sine y is equal to the cos of x sine y. And we don't even need to do that because they said that we should use sine x as a half. So we don't even need to do that. We can replace sine x with a half. Sine x is a half. So this is really a half cos y minus cos x. And now look what I'm going to do. Before I even go any further, I'm going to draw a triangle. All right. It's always easy with a triangle. If I draw a triangle with the angle x, the sine of x is opposite 1 over the hypotenuse 2. And so what that is telling me, if sine x is 1 over 2, then that is telling me that the adjacent is 2 squared, which is 4, minus 1 square rooted. So the adjacent is working out to be the square root of 3. All right. And so if that is the case, then what that is telling me then is that cos x is then telling me that cos x is equal to root 3 over 2. That's cos x. Cos x is root 3 over 2. So now we can do some substituting. Cos sine x is a half. Sine x is a half times the cosine of y minus cos x, and cos x is root 3 over 2. So root 3 over 2 sine y. And that's equal to sine x. Sine x is a half. We have a half cos y plus cos x again, which is root 3 over 2 sine y. First thing I want to do is multiply this equation through by 2. I don't like to be seeing so many half, 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 half. If I multiply through by 2, and I'm going to get that cos y minus root 3 sine y Let me put what I did right here. I multiplied through by 2. By multiplying through by 2, we get rid of that half in the denominator. And so what we end up get is cos y minus root 3 sine y is equal to cos y plus root 3 sine y. Now the cos y's are going to cancel clearly, right? If I bring cos y over here, cos y minus cos y becomes 0. Then if I bring over here the root 3 sine y over here, root 3 sine y, bring it over here, I'm going to get 2 root 3 sine y, 2 root 3 sine y is equal to 0. That's what I'm getting. 2 root 3 sine y is equal to 0. Now that I get that 2 root 3 sine y is equal to 0, I can divide by 2 root 3. And so then that means that sine y must be equal to 0. And if sine y is equal to 0, then that is telling me that y is equal to 0 or y is equal to pi. Those are the two answers. But the question told me that, remember they said that x is between 0 and pi by 2. So from this, yep, these are the two possible values. All right, 0, 2 pi. Let's see if there's any more possibility. If we go around the circle one more time, we can also get 2 pi. So these are the three solutions. All right. So we can conclude, therefore, y is equal to 0, or y is equal to pi, or y is equal to 2 pi. All right, nice. And you can actually test your answer and test it. We know that x is sine inverse of a half, which is pi by 6. So x is pi by 6. Try a value like y is 0. So if you have the sine of pi by 6 minus 0, this side would give you the sine of pi by 6, which is a sine of 30. Sine of pi by 6. This part is a half, and try this. This is good. Try when x is pi, when y is pi rather. Pi by 6 minus pi is going to be minus 2.61. Take the sine of that value. You get minus a half. Check it if you get the same over here. So pi plus pi by 6 and I'm getting the same. So these are the possible values of y. Y can be 0, pi, and 2 pi. Nice and easy. Soft. Let's go to the next part of the question. Next part of the question says, f of theta is 3 sine 2 theta plus 4 cos theta. And it wants us to express it in the r sine form. Let's go ahead and do that. It says f of theta is equal to 3 sine 2 theta plus 3 sine 2 theta plus 4 cos 2 theta. Nice and easy. That's f of theta. F of theta is 3 sine 2 theta plus 4 cos 2 theta. So if this is f of theta, right, and we want to express it in the r sine r cos form, the first thing is r is going to be equal to 3 square plus 4 square square rooted. That's r, and so that works out to be 5. And then theta is going to be equal to tan inverse of b over a. So theta is tan inverse. Theta is tan inverse of 4 over 3. So you put that in a calculator, what's tan inverse of 4 over 3? That gives you this value here. Tan inverse 4 divided by 3, that's 0.927. So what does that mean? That means then that f of theta is equal to r, which is 5, times the sine of 2 theta plus alpha, and alpha is 0.927. So 0.927. Nice and easy, soft. Okay, let's go to the next part of the question now. It says, hence or otherwise, determine the value of theta between 0 and 2 pi at which f of theta is minimum. So they want when f of theta is minimum. All right, so let's find minimum value. Value of theta for which f of theta is minimum. Now, first thing I want to tell you is that f of theta is always bounded between r and minus r. This is part 1 answer. This is part 1, right? That's in that form. And this is part 2. This is part 2a. So first thing, f of theta is always between 5 and minus 5. That's the first thing we need to know. It's always bounded between 5 and minus 5. Now, f of theta is equal to 5. F of theta is equal to minus 5. It's equal to minus 5 when is sine going to be negative? We know that the sine of an angle is negative. If I were to call all of this x, it is negative when the sine of 2 theta, all right, let me write it better. F of theta is equal to minus 5 when the sine of 2 theta plus 0.927 is equal to negative 1. All right, that's when it's equal to minus 5. And so we need to solve for theta in this case. So first thing we're going to do is take sine inverse to get that 2 theta plus 0.927 is equal to sine inverse of negative 1. All right. So sine inverse of minus 1, you're going to get minus pi by 2. So you're going to get sine inverse of minus 1 is minus pi by 2. Of course, generally you get 2 answers, right? You want when theta is negative, all right? Generally they tell you to draw a circle, and they tell you that sine is negative. Sine is negative in the 3rd and the 4th quadrant. And then you find the principal acute angle in the 1st quadrant, which is pi by 2. And so then it's going to be pi plus pi by 2. And so some people actually write pi plus pi by 2. Some people actually write pi plus, oh gosh. Let me see if I can get that back. Yeah. So in the third quadrant, as we said, the angle is what? In the first, it's pi by 2. The second, it's pi minus pi by 2. In the third, it's going to be pi plus pi by 2 when it is negative. And pi plus pi by 2 is 3 pi by 2. All right, so this is 3 pi by 2. That's one possible answer. Or, yes, or you're wondering where the or come from. Or it can be 2 pi minus pi by 2. 2 pi minus pi by 2. And 2 pi minus pi by 2 is 7 pi by 2. So let's solve for theta in this case now. Let's start with the first one. With the first one, we're going to have 2 theta is equal to 3 pi by 2 minus 0.927. 3 pi by 2 minus 0.927 is 3.78. So this one is working out to be 3.78. Then you divide through by 2 and you get theta is equal to, and you divide that by 2, you get 1.89. That's one possibility, 1.89. And this is in radians. Or the next answer would be 2 theta is equal to, you work out what is 7 pi by 2. 7 pi divided by 2 minus 0.927. And the other answer is giving me 2 theta is 10.1. And so this answer is giving me theta is equal to 5.05. But this answer is not valid. Not valid. Not valid. And this one is not valid. And the reason for that is because they told us, remember they told us that theta must be between 0 and 2. Theta must be between 0 and pi. Wait, actually this is fine. This is fine. It's between 0 and 2 pi. So those are what you're getting. Theta is either 1.89 or this theta is 5.05. If you don't believe me, put it in the calculator. 3 sine 2 times 1.89. 2 times 1.89. 3 sine that. Plus 4 times the cosine of 2 times 1.89. I get my negative 5 for this. I'm putting 5.05 as well. You get 3 sine plus 4 cos. I get my minus 5. So both of these are fine. These two are the answer actually. These two are the answers. All right, any one of them is fine. All right, 1.89 and 5.05. I know it says find the value, but both of them satisfies it. Now it says determine the maximum and minimum value of 1 minus 7, 1 over 7 minus f of theta. So let's do the final part of this question. So to do the final part of this question, first we have to start with by saying f of theta is going to be bounded. It's bounded between 5 and negative 5. We know this. Good. So if I were to say minus f of theta, If I multiply through by -1, that's bounded by 5 and -5. All right. And then if I add 7 to both sides, I would get that 7 minus f of theta is bounded by, add 7 to 5, I get that it's bounded by 12. And I add 7 over here, it's bounded by 2. I then reciprocate it, I flip it and reciprocate it, and I get 1 over 7 minus f of theta, and that's bounded by, that's going to be bounded by 1 over 12, and this is 1 over 2. Nice and easy, soft. So then the question you may ask now is, what is the minimum value of f of theta? So you can just say, okay, the minimum value is, the minimum value of that is going to be 1 over 12, and the maximum value is a half. That's how you do that question. Nice and easy, soft, no issues. That takes care of question number 3. Nice and easy. All right, we're on to question number 4. On to question number 4. Question number 4 says, let L1 and L2 be the diameters of a circle. The equations of L1 and L2 are x minus y plus 1 and x plus y minus 5 equals 0 respectively. Show that the coordinates of the center of the circle L1 and L2 intersect at 2, 3. So pretty much they're asking you to solve the equation simultaneously and show that the point of intersection is 2, 3. So you have a line x minus y plus 1, and that's equal to 0. And you have another line x plus y minus 5, that's equal to 0. If you're to add these two equations, let's just add them. If we add these two equations, we're going to get x plus x is 2x, y plus minus y cancel, 1 plus minus 5 is minus 4, is equal to 0, and so 2x minus 4 is 0, and so 2x is equal to 4, and so x must equal 2. X must equal 2. Since x is equal to 2, we can resubstitute in a point up here. All right, so 2 minus y plus 1 is 0, and so y must be 3. Y has to be 3. All right, and so hence the center is 2, 3. Hence, the center is 2, 3. So that gives us the center of the circle. Hence, the center is 2, 3. Now that we get the center of the circle, we're looking pretty good. All right, we're looking pretty good now that the center of the circle is 2, 3. So that represents part A. All right, center of the circle is 2, 3. Now it says A and B are ends of the diameter. So anytime they're talking about diameters and endpoints, I just have to draw a circle. It just gives me a clear idea of what's going on. All right, so I'm just drawing this circle here. And it just really helps me when I do that. And I know the center of the circle is 2, 3. I know the center of the circle is 2, 3. I know that the line, you have the line y is equal to x plus 1. If I bring this over, I have the line y equal x plus 1. So that's a line like this, y equal x plus 1. So this represents L1. That's L1. Then the line L2 would be, bring over this, it would be 5 minus x. 5 minus x is a line coming from down here. This would be the line L2. I'm just sketching it. It makes me see what they're talking about. And they said that A and B are endpoints of L1. So looking at L1, A and B are endpoints. So you have A and B. And they tell us that given that the coordinates of A is 1, 2. So A has coordinates 1, 2. And the diameter bisects each other, determine the coordinates of B. Now that's so easy. Like this is B. Like to get from here to here, remember the distance from here to here. Let me put it like this. The distance from here to here is the same as the distance from here to here. All right, so the distance from A to the center is the same as the distance from C to D. So there's two ways you can do it. You could use the length of a line formula and say that the distance AC is equal to the distance CD. All right, so given that the two distances are equal, then that implies that B is going to be equal to the coordinates 3, 4. You might say, how do I know that right away? Look at it. You're going up by 1 for the x. You continue by 1. From here to here is 1. So you increase in x by 1. So you go from 1 to 2 to 3. That's from A to the center to B. That's for the x coordinate. For the y coordinate, the distance is going to be the same. And so it's going to go from 2 to 3 to 4. That's the easy way to do it. All right, so B is a 0.34. Nice. Next now it says a point P moves in the xy plane such that its distance from C is 2, 3. Such that its distance from the center is 2, 3. And it says determine the locus of P. So it tells us that the distance from the center of the circle, so the distance from the center of the circle is √2. So if the distance from the center of the circle is √2, this is what you have. All right. I want to put a better sketch right here. And let me not use a circle yet. Let's say this is the center. This is C. C is the point 2, 3. And they're telling us that P is the point where P could be anywhere, P could be here, but all they're telling us is that P is the point such that the distance from the center to P is √2. So they're telling us that this distance is √2. So if this distance is √2, P could be anywhere. As long as the distance is √2, we could get one circle going around it. But as long as the distance as long as, let's say P is here, as long as the distance is √2, we're good. And so this forms an equation of a circle. And so the locus of P, the locus is going to be given by x minus 2 all square, because it forms a circle, so it's x minus 2 all square plus y minus 3 all square. And that's equal to r squared, which is the length of the radius, which is 2. That's the answer. Nice and easy. So this was a very easy coordinate geometry question. Everything about it was easy. Everything. Nice and easy. So Now let's look at the next part of it now. The next part should be parametric and vectors. So let's see. They tell us that the parametric equation is given by x is equal to 1 over 1 plus t, 1 over 1 plus t, that is x, and they tell us that y is equal to t over 1 minus t squared. Y is equal to t over 1 minus t squared. And then what they're asking us to do is they ask us to determine the Cartesian equation of S. So if we're to determine the Cartesian equation of S, that we need to make it in terms of y in terms of x or x in terms of y. So looking at it, this one looks easy to make t the subject. So from this one, I'll do it in a different coloring. I can see that 1 plus t would be equal to 1 over x. And so I would be getting that t is equal to 1 over x minus 1. Some people might want to write it as 1 minus x over x. That's the value for t. All right, so I'm going to substitute t as 1 minus x over x into y. I'm going to sub it into y. And so what I'm going to get then is y is equal to t, which is 1 minus x over x. And all of this is divided by 1 minus t squared. T squared is going to be 1 minus x all squared over x squared. That's t squared. Given that the question is 6 marks, I don't think they want us to stop here. So let's simplify it. I'm just going to write back the numerator as it is, 1 minus x over x. And it's now being divided by, now this one can be looked as x squared over x squared. And then this is now minus, simplifying what is 1 minus x all squared. That part is going to work out to be 1 minus 2x plus x squared over x squared. That's what we're going to get. So now if we're to continue now, we're going to get that y is equal to, that's 1 minus x over x, and it's being divided by, simplify the numerator here, x squared minus x squared cancel, minus and minus become plus, so it becomes divided by 2x minus 1 over x squared. Now whenever you're dividing two fractions, you can rewrite it as 1 minus x over x, and that's being multiplied by, when you change the sign from division to multiplication, you flip it to get x squared over 2x minus 1. And so x cancels out a x squared, x from the x squared. So the two going to cancel, and it cancels out this x. And so what we get then is y is actually equal to 1 minus x times x. Y is equal to 1 minus x times x over 2x minus 1. That is y. Nice and easy, soft. That's the answer. 1 minus x times x over 2x minus 1. That is y. Nice and easy. Now let's have a look at part C. Now that we're going to have a look at part C, for part C, let's look at part 1 first. For part C, we have that the points P, Q, and R are three vectors of a triangle PQR, and it says express each of the vectors PQ, QR, and RP in the form xi plus yj plus zk. All right, so let's do that. So we have vector PQ. First thing we need to know is that vector PQ is going to be equal to OQ minus OP. All right, vector PQ is OQ minus OP. It's always vector of the last minus vector of the first. So it's going to be OQ minus OP. So OQ, remember, let's write out what is OQ. OQ is actually, well, it has in a lambda in it, so let's put it in vector form first, just to be a little bit, safe with lambda. So minus 1 lambda 5, that's OQ, minus OP, and we know that OP is 3 minus 2, and 3 minus 2 and 1. So vector PQ is going to work out to be minus 1 minus 3 is minus 4i, lambda minus minus 2 becomes plus, lambda plus 2 times j, lambda plus 2 times j, and then we have 5 minus 1 is plus 4k. That's vector PQ. Nice and easy, soft. Now let's look at the next part. Now it says find QR. Now vector QR is going to be equal to OR minus OQ. That's vector QR. Vector QR is OR minus OQ. So I need to work out that what is OR minus OQ. OR, as we know it, vector OR is 2i. Again, because it have the lambda, I want to play it safe. Anytime it have lambda, I play it safe. I'm just going to put it in vector form first and then convert it to ijk. So OR is 2, 1 minus 4, 2, 1 minus 4, minus vector OQ, and vector OQ is minus 1 lambda minus, so it's 2, 1 minus 4. This is now minus 1 lambda and 5. So 2 minus minus 1, that works out to be 2 minus minus 1 is 3, so that's 3i, plus 1 minus lambda j, 1 minus lambda j, then you have minus 4 minus 5 is minus 9k. So that's vector QR. Now that we get vector QR, next thing we need is vector RP. Let's work out what's vector RP. Vector RP is equal to OP minus OR. Vector RP is OP minus OR. All right, since vector RP is OP minus OR, now this one I can just go straight because OP, remember where was OP? This was OP, OP minus OR, this was OR, so OP minus OR, that's going to be 3 minus 2 is 1. That's just I. And you're going to have minus 2 minus minus 1. Minus 2 minus 1 is minus 3j. Let me write this better. Minus 3j. Then you're going to have 1 minus minus 4 is plus 5k. Nice and easy, soft. Nice and easy. One minus minus 4, just making sure. Yes, that's 5k. So now we have these all good. Now it says, hence find the value of lambda given that PQR is a right angled triangle with side PQ as the hypotenuse. So again, guys, I love to see a picture of what's going on. I cannot just do it like that. I have to get a picture. So I'm creating my X and Y axis. I know it is X, Y, Z, but ignore the Z coordinates. So OQ is minus 1 lambda. OP is 3 minus 2. So think of it this way. 3 minus 2 is here. So this is OP. Just ignore the Z component for now. This will be OP, right? And then you have OR 2, 1, 2, 1, 2, 1, somewhere here. This is R. All right, so remember P is we're only looking at the X and Y coordinates. So it's 3 minus 2. R is the point 2, 1. And then we don't know where Q is, but based on what they said that PQ is a hypotenuse. So PQ is the longest side. PQ is the longest side. So where can we put Q? PQ is the hypotenuse. So maybe Q is somewhere here. I'm just putting a point, all right? Just putting a point. Well, actually, Q is minus 1 lambda. Q will be somewhere over here. All right, so let me not draw that yet. Q is somewhere over here. Let's say Q is right here. All right, let's say this is Q. So those are the 3 points, and I'm saying, imagine this now. Say have right angle triangle PQ. PQ is the hypotenuse, and so then that means that the right angle would have to be somewhere at PR. All right, the right angle is somewhere right here. All right, the right angle is somewhere right here. All right, and this is the hypotenuse. And so now we need to determine the value of lambda. To determine the value of lambda, since this is a right angle triangle, then we know that the dot product is 0, or you can know that the angle at R is 0. So generally, what that means is, since we have QR, you know that QR dot PR must be equal to 0, right? So since the angle at R is 90, this is part 2. Looking at the diagram, right, we know that since triangle RPQ is a right angle triangle, since it's a right angle triangle, since it's a right angle triangle, then what that is telling us then is that QR dot, the dot product between QR, so QR dot PR must be equal to 0. So we're going to use that dot product to solve for lambda. So doing that now, QR is 3, 1 minus lambda, minus 9, that's QR, dot RP, dot RP. RP would just be in the opposite direction to this, so this would just be minus 1, positive 3, minus 5, and that's equal to 0. So what does that mean? That implies that 3 times minus 1 is minus 3, plus 3 times 1 minus lambda is 3, minus 3 lambda, and then minus 9 times minus 5, that's plus 45, that's equal to 0. So what does that tell us? That tells us then that 3 lambda minus 3 plus 3 cancel each other, and so 3 lambda is equal to 45. 3 lambda is 45, and so lambda is 15. So lambda equals to 15. That's the answer. Lambda is 15. I don't see why you get 6 marks for this. They were very generous, but that's it. Nice and easy, soft. Lambda is 15. And now we go to module 3. Module 3, we're going to start with question 5. With question 5, it says, let f of x be a function defined as ax plus 2 over ax squared. Find the value of a if f of x is continuous at x equals 3. If f of x is continuous at x equals 3, then that means that the limit from both sides are equal. So they're telling us that the limit as x approaches 1, that's 3. They're telling us that the limit as x approaches 3 of ax plus 2 must be equal to the limit as x approaches 3, because the limits on both sides are equal. Left hand limit is equal to right hand limit. And so the limit must also be equal to ax squared. So when you plug in the 3 now, you're going to get 3a plus 2. 3a plus 2 is equal to, plugging in 3 now, you're going to get 3 squared is 9, so you get 9a. I will bring over the 3a to get 2 is 6a, and since 2 is equal to 6a, you divide by 6 and so a must equal to 1 over 3. Alright, so that's the value of a. Alright, so hence a is equal to 1 over 3. A is equal to 1 over 3 for f to be continuous. For f to be continuous, a is equal to 1 over 3. Nice and easy. Part 2. Part 2 says, let g of x be x squared plus 2 over bx squared plus x plus 4. And it says, given that the limit as x approaches 1 of 2g of x is equal to the limit as x approaches 0 of g of x, find the value of b. Alright, so let's do that. So part 2. Alright, given that the limit as x approaches 1 of 2g of x, and that is equal to the limit as x approaches 0 of g of x. Find the values of a and b. Now, looking at the function, looking at g of x is x squared plus 2 over bx squared plus x plus 4. So we're going to apply x as 1 first. When you apply x as 1, you're going to get 2 times in the, putting x as 1, you're going to get 2 times 1 squared plus 2 is 3. So 2 times 3 over 1 squared times b is b plus 1 plus 5. So that's 3 over b plus 5. And that's equal to, plugging in 0, you're going to get 2 over, plugging in 0, you get 0, you get a half here. When you plug in 0, you get a half on this side. So now we just need to transpose for b. So from this, the 2's cancel on both sides. I'm going to cancel this 2 here. I'm going to cancel this 2 here. Then I'm going to cross multiply. I'm going to cross multiply to get that. Cross multiplying, I get that 4 times 3 is 12. And so 12 is equal to b plus 5. And if 12 is equal to b plus 5, then b must be 7. So hence b is equal to 7. That's the value for b. B must equal 7. Nice and easy, soft. No issues right there. Now let's look at part 2. Part 2bi. So the limit as, alright, it's not limits anymore, this is differentiation. So part B says y is equal to 1 over root x. So it tells us that y is equal to 1 over the root x. And it says using differentiation from first principle, find dy by dx. So first thing you have to remember from first principle, that dy by dx, using first principle, is equal to 1 over h times the limit as h tends to 0 of, it's 1 over h times the limit as h tends to 0 of f of x plus h minus f of x. This is the formula to find dy by dx. It's f of x plus h minus f of x. Alright, and so what we're going to get then is dy by dx is equal to 1 over h times, you just need to plug in now f of x plus h. Plugging in x plus h in here, you're going to get 1 over the square root of 1 over the square root of x plus h minus f of x, and f of x is just 1 over root x. That's dy by dx, alright? Oh, I forgot to put in my limit. It's 1 over h times the limit as h tends to 0 of this. Oh gosh, I forgot my limit. 1 over h times the limit as h tends to 0 of this. Let's see how we're gonna simplify this now. To simplify this, first we have to join it as one fraction. All right, so join it as one fraction to say dy by dx is now 1 over h times the limit as h tends to 0, limit as h tends to 0 of the limit as h tends to 0 of, multiply up this to get root x minus the root of x plus h and that's over root x times root x plus h. All right. So this is what we have now. Now when you get to this stage now, you can tackle it in two ways now, but the shorter approach is going to be to multiply by the conjugate of the numerator. So now we're going to multiply by the conjugate of the numerator. So dy by dx is going to become 1 over h times the limit as h tends to 0 of. Let's plug in. Let's work out that now. Let's write it out first. There's no need to skip any steps. So like write root x minus the root of x plus h over root x times root x plus h over root x times the root of x plus h and that is multiplied by the root of x plus the root of x plus h. So multiplied by the conjugate. And anything you do to the numerator, you have to do it to the denominator. You have to multiply the denominator also by the root of x plus the root of x plus h. Anything you do to the numerator, you have to do to the denominator. All right, nice and easy, soft. Now that we're multiplying by the conjugate, in the numerator, it's going to become 1 over h times the limit as h tends to 0 of, now in the numerator becomes the difference of 2 squared. So it's going to simplify out to just be root x times root x is x. It's going to be a squared minus x plus h. So it is x minus x plus h over root x times the root of x plus h, root x minus the root of x plus h times root x plus root x plus h. Now the thing is, we're always trying to cancel this h right here. To cancel this h right here, what you realize is that this part in the numerator is going to simplify out to just be x minus x cancel. So in the numerator works out to just be minus h. All right. Now we always want to cancel this h. This 1 over h, this h out here cancels this h. So you end up just left back with minus 1 over this. Now when you cancel out this h, now you can apply h being 0. And so it works out to be minus 1 over, plugging in 0 now, root x times root x is just root x times root x is x. So you get minus 1 over x times, plug in h as 0 here, root x plus root x is 2 root x. This is 2 root x. All right, nice. So this works out to be minus 1 over 2x root x. Nice and easy. So that's dy by dx. This is the answer. 2x root x. That's dy by dx. Alright? Now, if you don't believe your answer, you can always check it. That's the beauty about first principle. You can know when you're right. You don't need an examiner or your lecturer or your teacher or wherever you do math. You don't need anybody to tell you if you're right, because you can differentiate it to say if y is equal to 1 over root x, in reality, y is x to the minus half. If I am differentiating x to the minus half, then I would get that dy by dx. In reality, dy by dx would be carry down the power, which is minus a half, subtract 1 from the power, which is x to the minus 3 over 2. And so what you'd realize is that dy by dx, x to the minus 3 over 2, is actually minus 1 over 2 times x cubed all square rooted. That's dy by dx, but this can be simplified to be minus 1 over the square root of x cubed. You can write that as 2 times the square root of x squared times the square root of x. And then the square root of x squared is just x. And so you still get that dy by dx is minus 1 over 2x root x. So this is just confirmation that our answer is correct. This is confirmation. This is just confirmation. Confirmation. Just confirmation. All right, nice and easy. Now the second part of the question says, it says if y is equal to x over the square root of 1 plus x, determine an expression for dy by dx. So it says y is equal to x over the square root of 1 plus x. Y is equal to x over the square root of 1 plus x. So if y is equal to x over the square root of 1 plus x, find dy by dx. I'm going to use implicit differentiation. All right, I can't bother to work with, oh, well, let's not do that then. I just couldn't bother work with the square root. Let's just differentiate it normally. So dy by dx is equal to, you start with the bottom, which is 1 plus x square rooted times the differential of the top. The differential of x is 1, so minus the top being x times the differential of the bottom. The differential of the bottom is carry down the power half, then you subtract 1 from the power, which is 1 plus x to the minus half subtract 1 from the power, yeah, divided by the square of the denominator, which is 1 plus x. Better to use implicit. I wouldn't have to be working with no negative powers. So yep, square root of 1 plus x, carry down the half, subtract 1 from half is minus half, times the derivative inside the bracket of 1. So this is fine. So simplifying this, we're going to get that this is equal to the square root of 1 plus x minus Now this part can be written as minus x over 2 times the square root of 1 plus x. All I'm doing is simplifying this, and all of this is divided by 1 plus x. The question said to simplify your answer fully so you're not finished. You can then write that this is going to be multiply up 2 times the root of 1 plus x, and you're going to get 2 times the root of 1 plus x times the root of 1 plus x is just 1 plus x. So you get 2 times 1 plus x. You get 2 times 1 plus x minus x over 2 times the root of 1 plus x divided by 1 plus x. Which is equal to this divided by this now, 2 plus 2x minus x. That's going to be 2 plus 2x minus x. That is this divided by this. It's simplified. 2 plus 2x minus x is just 2 plus x. So all of this just works out to be 2 plus x divided by this. So it's going to work out to be 2 plus x divided by 2 times the square root of 1 plus x times 1 plus x. Nice and easy. That's the answer. 2 times the square root of 1 plus x times 1 plus x in the denominator. Alright, that's the answer. Now, would implicit have been easier? Or, this is for persons that would have wanted to do it implicitly. You could have done it implicitly by going squaring both sides. You'd have gotten y squared is equal to, that would have been x squared over x squared over, when you square this, the square would cancel. So you just get 1 plus x. Alright. And then I'm going to rewrite this as x squared times 1 plus x to the negative 1. I'm going to use implicit. Using implicit, differentiating both sides now with respect to x, you'll get 2y times dy by dx, 2y dy by dx. That would be equal to, keep the first, that means times, keep the first, times the derivative of the second. The derivative of the second would be carry down the power minus 1, subtract 1 from the power to get 1 plus x to the minus 2, plus keep the second times the derivative of the first, plus keep the second times the derivative of the first, which is 2x. This is telling me that 2y dy by dx, if I had to continue around here, I'm getting 2y dy by dx. This is if you wanted to do it implicitly. 2y dy by dx would work out to be equal to, this part is going to simplify to be minus x squared over 1 plus x all squared. This would be minus x squared over 1 plus x all squared Then I have plus 2x over 1 plus x plus 2x over 1 plus x. And so I could then divide through by 2y. Dividing through by 2y, that would then tell me that dy by dx is equal to, dividing through by 2y, I would get that it is equal to minus x squared over 1 plus x all squared times y plus 2x over 1 plus x times y. And then you could resubstitute what y is. Remember what was y? Y was x over the square root of 1 plus x. So you could resubstitute then and get that. It's a good thing we didn't do it implicitly. It's actually a longer method. So we get that dy by dx would be minus x squared over, this would be 1 plus x squared, 1 plus x all squared times the square root times y now, and remember y in this case is x over the square root of 1 plus x plus 2x times 1 plus x times y, and y would be x times the square root of 1 plus x. This is way longer, implicit, so don't do implicit there. 1 plus x. And then to simplify this now, and you'd want to say, oh gosh, I have to simplify this. Yes, to simplify this now, you would have to go that this would become minus x squared over 1 plus x squared times x. Remember, 1 plus x squared is 1 plus 2x plus x squared. And then you multiply that by x. It would be 1 plus x squared times x, 1 plus x squared, 1 plus x all squared. And this would be times x. And it would be all of this is divided by the square root of 1 plus x. Now when you have this now, let me just do it in one step. Think of it as a divided by b over c. It works out to be a times c. So I'm just going to do it in one step. All of this, I'm just going to do it in one step. A divided by b over c is a times c. So it works out to be minus x squared times the square root of 1 plus x over x times 1 plus x squared. And then as you realize, for this side, the x cancels the square. And then this part will give you plus, it's going to be 2x times the square root of 1 plus x over, this is x times 1 plus x and this x cancels this x, and so the final answer that you get is pretty much the same as the other one. The final answer is the exact same thing. We just need to simplify it some more. So in this case, it gives us that dy by dx is minus, we could make the LCM 1, and so it is minus x. If you want to make the LCM 1, it's really minus x times 1 plus x times the square root of 1 plus x plus 2 times the square root of 1 plus x over 1 plus x. All square. So this is dy by dx. All right, this is an alternate way to do it. You could actually factor out 1 plus x. The square root of 1 plus x, you could factor that out and simplify in the bracket. You're going to eventually get back the same thing. All right? So either way you do it is fine. Either way. Now part C. Part C tells us that dy by dx, it says x is equal to cos theta. So let's do that. X is equal to cosine theta. X is equal to cosine of theta. And it tells us that y is equal to the sine of theta. X is equal to cos theta and y is equal to the sine of theta. And so first thing we need to find is dx d theta. So dx d theta, when you differentiate cos, let me write that better. That's not gonna look too pretty. So when you differentiate with respect to theta, so dx d theta is going to be equal to, when you differentiate cos, you get minus sine theta. All right, when you differentiate cos, you get minus sine. And then when you differentiate, you find dy by dx, or dy by d theta. When you differentiate sine, you get cos. All right, nice and easy. So what does that mean? That means that dy by dx, is going to be equal to dy by d theta, times d theta, times d theta dx. And so it's going to work out to be dy by d theta is cos theta times d theta dx, which is really divided by the minus sine theta. But then cos over minus sine is minus cot. And so dy dx is minus cot theta. All right, nice and easy. That's what we have, minus cot theta. All right, nice and easy. And this takes care of question 5, solved. All right, finally, question number 6. Question number 6 says the gradient of a curve passes through the point -1, -4, and is given by, it tells us that dy by dx is equal to 3x squared minus 4x plus 1. And it says, find the equation of the curve. To find dy by dx, right, since you already have dy by dx, then the equation of the curve y is going to be equal to the integral of dy by dx. So y is equal to the integral of 3x squared minus 4x plus 1. That's dy by dx. 3x squared minus 4x plus 1 dx. That is y. So now you integrate that, and what you're going to get is 3x cubed. You get 3x cubed over 3 minus, add 1 to the power, you get 4x squared over 2 plus 1, that's just x, alright, plus some constant c, alright, and that's the equation of the curve. If you want to go ahead and simplify it, you're going to see that y is actually just x cubed minus 2x squared minus 2x squared plus x plus c. Nice and easy. Now you need the point minus 1 minus 4. So at minus 1 minus 4, at minus 1 minus 4, y is minus 4. So it's going to be minus 4 is equal to minus 1 cubed, which is minus 1, minus 2 times minus 1 squared plus minus 1 plus c. That will allow us to find the constant c. Alright, so solving for c, we're going to see that minus 4 is equal to, put it in the minus 1, we get minus 1 minus 2 times minus 1 squared plus minus 1. That is negative 4. So minus 4 is equal to negative 4 plus c. And so the constant is 0. So if the constant is 0, the curve passes through the origin. And so hence the curve is going to be, this is part I. The curve is just going to be y is equal to x cubed minus 2x squared plus x. Nice and easy. So now the second part of the question says, find the coordinates of the stationary points and determine their nature. So to find the coordinates of the stationary points, well, that's no issue. So we go ahead now and to find the coordinates of the stationary points, we go ahead and solve dy by dx equals 0. So we solve dy by dx equal to 0. We solve dy by dx equal to 0. By solving dy by dx equal to 0, we are solving 3x squared minus 4x plus 1 equal to 0. And by solving this equal to 0, we factorize it. By factorizing it, what we're going to get is signs are the same, and both of them is negative. So this is minus, minus, this has to be x, and 3x. And so the stationary points are going to occur when x is equal to 1, or when x is equal to 1 over 3. 1 upon 3. So now that these are the two stationary points, what do we do? Now x is 1, we need to find y. When x is 1, we plug in 1 here, we have 1 cubed minus 2 times 1 squared plus 1. So when x is 1, we get y is 0. Then we'll put in 1 over 3. So then we're going to have 1 over 3 cubed minus 2 times 1 over 3 squared plus 1 over 3. And that's 4 over 27. So this is giving us y is 4 over 27. So those are the two stationary points. So let me just put it as a point. You have 1, 0, and you have 4 over 1 over 3, 4 over 27. That's another stationary point. 4 over 27. Now you need to find out what is dy by dx. Now it says determine their nature. So since we need to determine their nature, we need to find the second derivative to do that. So the second derivative d2y by dx squared, that's going to be equal to, you differentiate dy by dx to get 6x minus 4. All right, 6x minus 4. Now at the point 1, 0, at the point 1, 0, the second derivative, don't, just for space, second derivative is often written as y prime prime, meaning you differentiate y twice. At 1, 0, y prime prime is equal to, you plug in 1, you get 6 times 1 is 6 minus 4 is 2, which is greater than 0. And so therefore 1, 0 is a minimum point. So 1, 0 is a minimum point. And then now you need to find y prime prime over here. At 1, 3, at the point 1, 3, you have y prime prime is going to be equal to, when you plug in 1 over 3, you get 6 times 1 over 3, 2 minus 4 is negative 2, which is less than 0. And so 1, 3, 4 over 27 is a maximum point. So this right here is a maximum point. That's a maximum point. Nice and easy. So we have the minimum point and we have the maximum point. Now that we have the minimum point and the maximum point, it says hence sketch the graph. So to sketch the graph now, we create our, I like to sketch it first. So let's like to do what's called a freehand sketch. That's my freehand sketch. All right. This is the maximum turning point, the minimum turning point, and I label them. This is the point 1, 0. And this is the point 1 over 3. 1 over 3 and I think it was 4 over 27. I like to do a freehand sketch first and then label the axis. All right, so now I can label axis. Now x-axis is right here. When y is 0, that's the x-axis. Yeah, that should be fine. Now the y-axis now occurs when x is 0. So if this is 1 over 3, we can put the y-axis somewhere here. That's the y-axis. And how do I know it is right there? Because the question had told us how to make the line straight. Yeah, so that's the y-axis. So making sure you label all intercepts. So let's label them. In labeling all the intercepts now, we had our maximum stationary point. We labeled that already, 1 over 3, 4 over 27, minimum stationary point, 1 over 0. And this is also a root, And the next root is when x is 0. So next root when x is 0. Alright, so that's the point 0, 0, which is the origin. Alright, so if you want to tell them and just write down, just to tell them that your roots are, just tell them the roots are 0 and 1. Tell them that your y-axis intercept is the point 0, 0. And then you already have your minimum stationary point. Minimum stationary point. The minimum stationary point is 1, 0. You can tell them your maximum stationary point from your graph, maximum stationary point. That is the point 1 over 3, comma 4 over 27. There we go. Nice. Let's go to part B now. Part B says we are supposed to evaluate the integral from 0 to 3. Evaluate the integral from 0 to 3 of 2x plus f of x is 2x times the square root of 1 plus x. Evaluate the integral from 0 to 3 of 2x times the square root of 1 plus x dx. Now to do this integral, right, you can use substitution. So you can call u is equal to 1 plus x. Oh, this is 1 plus x squared. So u is equal to 1 plus x squared. If u is equal to 1 plus x squared, then du is going to be equal to 2x dx. This is 2x dx. And so then that means that the upper limit, you're going to change the upper limit. The upper limit is going to be equal to, when x is 0, the upper, when x is 3 rather, 3 squared is 9 plus 1 is 10. So the upper limit becomes 10. And the lower limit is going to become, put in x as 0, and then 0 plus 1 is 1. And so now we can rewrite this as the integral now from a new lower limit of 1 to an upper limit of 10 of, this is now 2x dx is du, and 1 plus x squared is u. So this is now the square root of u. So it's 1 to 10 of the square root of u du. Doing this integral, this is u to the half. So we add 1 to the power to get u to the 3 over 2, divide by the power of 3 over 2. And we're integrating that from 1 to 10. Nice and easy, soft. So you work that out now. You plug in 10. First and foremost, 1 over 3 over 2 is 2 over 3. So I'm going to factor out the 2 over 3. Write it as 2 over 3 times. This part can be written as u cubed square rooted from 1 to 10. I'm just making it a little prettier. Now you can find the integral of that. That's going to be equal to 2 over 3 times, when you plug in 100 cube, so you plug in the cube root of 1. Where does 100 come from? That should be 10. 10 cube square rooted minus 1 cube square rooted, and you work that out. So that's going to be 2 over 3 times 100 cube is 1000 And the cube root of 1,000, the cube root of 1,000, right there, 10 cube, then we square root 10 cube, then we subtract 1, then we multiply it by 2 over 3. I was trying to write this as a pretty answer, but it's not coming to me, so I'll just leave it exact. It's 2 over 3 times the square root of 1,000 minus 1. I wanted to write it pretty up, but it's not coming to me right now. Maybe we can break this down using surds. Right, we can break that down as maybe 4 times 250. Yeah, we could break this down using surds. We could. We could actually break this down using surd. Maybe you could break it down as 2 over 3 times. I just like when it looks prettier. 1,000 is really 25 times 40. And so that's 5 times the root of 40. And the square root of 40 can be broken down as 4 times 10. And the square root of that, just trying to write it prettier. Let me see. That's 2. 2 times 5 is 10. Yep. So I can write it as 10. 10 root 10. Yeah, this looks better. 10 root 10. 10 root 10. 10 root 10. Yeah, this looks better. 2 over 3, 10 root 10 minus 1. It looks better to me. It's not annoying anymore. So that's that. Nice. Okay, let's continue. It says find the volume generated by rotating the area bounded by the curve above in the x-axis and the line x equals 0 and the line x equals 2. So remember, volume around x-axis is equal to pi times the integral of y squared dx. It's pi times the integral. So volume is going to be pi times the integral from 0 to 3 of 2x times the square root of 1 plus x squared. 2x times the square root of 1 plus x squared. It's all of the square dx. That's going to be the volume. So that's going to work out to be pi times the integral from 0 to 3 of 2x squared. It's going to be 4x squared. It's going to be 4x squared multiplied by 1 plus x squared. That's when you expand the perfect square. This is what you'll get. Let me fix this one. Supposed to be 1 plus x squared. Close the bracket there. And then I work this out. And I work this out. And I get pi times the integral from 0 to 3 of 4x squared times 1. That's 4x squared. Plus 4x squared times x squared is 4x to the 4th power dx. Alright, and then now I'm able to include by adding 1 to the power to get 4x cubed over 3 divided by 3 plus add 1 to the power to the 4x to the 5th divided by 5 and I'm integrating from 0 to 3. That's going to be equal to, and remember all of this is multiplied by pi. So it's going to be equal to pi times, let's plug in the 3, we don't need to plug in 0. Just checking to make sure we squared it properly. 2x squared, 2 squared is 4, x squared is x squared, the root of 1 plus x. When you square that part, it's going to be root, the square cancel the square root to get 1 plus x. When we expand this, then we get 4x squared plus 4x to the 4, so we're fine. Add 1 to the power, divide by the power, so we're good. So plug in 3 now. We're going to have 4 times 3 cubed divided by 3, that's 36, plus 4 times 3 to the 5th power divided by 5, 4 times 3 to the 5th divided by 5, that's 194.4. And so you add those together and you get the volume. So when you finish, the volume is going to be 194.4 plus 36, which is 230.4 pi. 230.4 pi. And remember, volume is in units cubed. Nice. Now, the only issue is that you have this. Some persons like to express it in fraction. So some people might probably want to write it as 1,152. Maybe you want to write it as 1,152 over 5 pi. If you write it like that, that's totally fine. If you want to write it like that, 1,152 pi units cubed, that's no problem. So this takes care of this paper, and it was nice and easy, no sugar, it was just plain and simple, and I just wish you all the best practicing for your exam.